Alright, this is still from section basically 1.2, or that's at least where we're going to put it at. And this is going to be talking about significant figures. We don't always sit in a lab, obviously, and use measuring devices. We're going to be like given math problems, and so how do we take into account our measuring devices within our like homework type problems? And so scientists came together and they put together these rules called significant figures. So basically significant figures, we call them Sig Figs, take into account the uncertainty of a single measurement, so that we can do that without having to get out all the equipment and actually do labs and that sort of thing. The last measurement within, or the last digit or whatever within our numbers are always considered to be the uncertain digit. Okay, so let's start talking about all the rules. Okay, so there are a couple of different rules. First of all, if it is a number that is not a zero, so 1, 2, 3, 4, 5, 6, 7, 8, 9, they count. Alright, so like this number here, 1, 2, 7, 8, 9. Those all count. So this one has 5 Sig Figs. Okay, pretty straightforward. It's when we get into the zeros that it kind of gets a little confusing. So yes, and I said confusing. Alright, so here's where we get into it. Zeros. Leading zeros. They lead the pack. Okay? Leading zeros do not count. Okay? You do not start counting until you hit your first non-zero digit. Meaning I'm going to start going. I don't start counting until I hit a 2. Okay, so in this case this has 2. Okay? Same thing here. Don't start counting until you hit the 3. This one also has 2. Because 3, 6, both those count. 2, 5, both those count. Okay? So leading zeros, they lead the pack. They start out a number, they don't count. You don't start counting until you hit a number that is not a 0. So that's your first rule as far as zeros go. Captive. Okay, if I'm captive, that means I'm caught. Captive zeros always count. So, alright, so here's a good example. I'm working my way across, I hit a 2, that means I start counting. So, this 2 counts, this 2 counts. Alright, now I've hit a 0. Does this 0 count? Well, it's caught between 2s and 5s. So yes, same thing with this one. So, all these digits count. So 1, 2, 3, 4, 5. 5 significant figures. And we'll really talk about it. There's only 2 instances where zeros really don't count. So for the most part, count them. This is one case. Those beginning zeros don't count, so don't count them. So I don't start counting until I hit the 2. I've hit the 2, so start counting that 0 now. That 0 counts, 5 counts, 6 counts. So that would be 4 significant figures. Okay. Now, here is your other case where a 0 would not count. And this is horrible English, I understand this, but this is how I remember it. No decimal, no count. Okay? So if there's absolutely no decimal in the number, the zeros do not count. So look, okay, I'm working my way across. Maybe if my pen will work. Okay, there we go. I hit my 1, that counts, but look, is there a decimal there? Nope. So it doesn't count. So the only number that counts in this number is the 1, so this only has 1 significant figure. Look at the next example though. I start counting, I hit my first non-zero digit, it's a 1, but look, this one does have a decimal, so they count. So this one has 3. So there's only really 2 instances where your zeros don't count. It would be these right here. I'll skip down, this is a good example right here. And I'll change colors so you can go back up here. And like this right here, these zeros. Those are the only 2 places where zeros don't count. So that's what I'm saying. If all else fails, almost 90% of the time, count them because look, look how often they count. So let's look at this example like 3 here. Okay, so we hit our first non-zero digit with the 2. It has a decimal, so you got to count all those. Okay, so let's see, that one have 1, 2, 3, 4, right? Let's look at this fourth example here. Okay. Now, the beginning, I already boxed that off because I was showing you that as an example of those that you don't count. You don't start counting until you hit your first non-zero digit. And that's the big thing if you remember. I can't count anything until I hit an actual number like 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I've hit a number and there's a decimal in the problem. Look for those two things, a real number and a decimal. I have a real number and I have a decimal. So these count now. So this would be right here, 4. So there you go. Okay. Okay, two other things. These right here, if they ever give you like 1 inch equals 2.54 centimeters, or, you know, an exact counting of something, I counted out exactly 1, 2, 3, 4, 5 basketballs. Those have infinite number of significant figures, meaning that they go into infinity. So that's going to be kind of important later. One more thing I don't think I have on the slide. Let me go back up here. So I have some paper. Something I want to point out is this. I'll just write it over here to the side. Let's talk about a number that's in scientific notation, like 2.05 times 10 to the 4th. Okay? If you ever get a number that's in scientific notation and they say, how many sig figs is this? You totally ignore everything right here. You only look at this. So in this case, this one, we have a 2, that counts. We have a decimal, so we go everything, so that would be 3. Okay, let's try this one. 3.00 times 10 to the 4th. Oh, I guess it would help if you could read that. Scoot it over here, we can see it here. Let me just clear all. Okay, how about 3.00 times 10 to the 4th? Okay, so again, this, don't care about, not part of Sig Figs. It's part of the number, right? It makes a big difference. There's a big difference between 3 and 3 times 10 to the 4th. If not, I'll give you $3. You give me 3 times 10 to the 4th dollars. Okay, okay, we hit our first non-zero digit. There's a decimal there, so all those count. So that's 4. Oh, sorry, I can't count. 3. I got 4 on the brain. So that's Sig Figs. We'll do some, again, I've got some practice on the bundle for you. Practice those, and we'll do some calculations with those later.